In today's episode, Michael asks, have you heard of augmented analytics as defined by Gartner? It seems to me it means your job will get easier in the short run and you'll be out of business in the long run. If you believe it, I'd be interested in your comments on it. So I took a look at the article that Michael had shared about augmented analytics, and fundamentally, after you read through it, it is as consulting firms are often doing, is their branded spin, or their branded name on something very common. Augmented analytics is what the rest of the world calls automated data science, the ability to use machine learning and AI technologies to take a data set and transform it and do a lot of the analysis and insights generation from that data set. Automated data science is, it holds a lot of promise, but the challenge is in, when you look at the data science lifecycle, there is a stage which they cite in the article, the data preparation is 80% of the data scientist's work, and it's mundane work, which isn't really true. That's something that's said often by people who are not data scientists. Feature engineering as a subset of that is probably the most important part. So there's really, when you think about it, there's sort of three parts to this section of data science. There is getting the data, there's cleaning the data, and then there's preparing the data for usage. Getting the data, yes, something that is automated, should be automated, because pulling data out of APIs and things is a very, very programmatic process, and it should be. Cleaning the data, again, something that can be automated to some degree. There are a number of good machine learning tool libraries that can help you clean your data. The hard part is the preparation of the data, and this is done a process that is called feature engineering. And feature engineering simply means finding ways to make the data set more valuable and more useful for machine learning modeling. And there's four parts to it that are important. There is feature extraction, which is when you are creating features, or you're doing processing on features. I should clarify, a feature is nothing more than a dimension. If you think about in Google Analytics, for example, there are dimensions and metrics. Metrics are the numbers, dimensions are the aspects. So metrics are how many visitors did you get to your website. Dimensions are which sources did they come from, like Facebook or email, and so on and so forth. Dimensions are not numbers, metrics are numbers. So when we're talking about feature engineering, we're talking about engineering additional dimensions and metrics from the dimensions and metrics you already have. So, for example, in a tweet, a dimension would be the date, right? And you could engineer additional things from that date, such as the year, the month, the day of the year, the day of the month, the day of the quarter, and so on and so forth. Simple feature extraction like that, or what's called one-hot encoding, which is an aspect of turning words into numbers. So if you had a database of days of the week, Sunday would become a 1, and Monday would become a 2, and so on and so forth. That stuff, yes, machines can easily automate it, and is something that machines absolutely should do. When it comes to feature extraction, though, things like labeling get very, very tricky. Again, marketers see this a lot in things like sentiment when you try to assess, is a tweet positive, neutral, or negative? Well, there's a lot of judgment that goes into that kind of labeling, and machines are getting better at it, but still are not great at it. And when you have limited label data, especially for more complex data sets, yes, again, there are machine learning algorithms like active learning that are starting to help, but they are still very, very limited in what they can do. For example, labeling your data. Is this a customer service tweet? Is this a sales tweet? Is this an advertising-related tweet? Who should this tweet go to? I'm using Twitter stuff as an example because it's very easy to see the applications. Those labels are not something that a machine comes out of the box knowing how to do, and you have to provide that labeling. The second aspect of feature engineering is called estimation and selection. What features are relevant to the modeling you're trying to do? If you're building a machine learning model and you just throw all the data at it, you're going to have exponential amounts of compute time required in order to be able to understand, like, have the model run correctly. So that's something, again, a machine can very easily do that kind of estimation and selection, and that is something that you absolutely should not attempt to do by hand. The third and fourth aspects are the ones where augmented analytics, as Gartner calls it, or automated data science, really start to run into trouble. Feature creation which is a subset really of extraction in many ways, is largely a creative task. What features should we create? Just because you can create day or week or month, should you? Right? If estimation and selection is about winnowing down the features to the ones that are useful for a model, creation is adding new ones and knowing which ones to add and which ones not to add, what's relevant, what's not relevant. So it's a very, again, creative task that machines will be able to, at some point, do a sort of a general best practices version, but it will be difficult for them to come up with all the possible combinations, at least until machines have much larger data sets to work with, and we build those active learning algorithms. The fourth one is one where I think machines have a significant amount of trouble and will for a long time, and that is feature imputation. This is, when you look at a data set, knowing what's missing from it. So recently I was looking at Marketing Over Coffee's podcast data, and I wanted to run some machine learning models to figure out what drives things like downloads or episode popularity. And I had Google Analytics data, and I had our podcast download data, and I had search data, and I had social media sharing data. And I forgot one. I forgot to get the subscriber data from FeedBurner, which is admittedly a pretty big omission, and clearly was not was not having enough coffee that day. I had to know from my domain experience that data set was missing. That's something that machines will have a very difficult time doing. And yes, for the most valuable, most important models, it is likely that machines will be able to have baselines, general best practices. Hey, these features should be in a data set like this. But that's a long way off, and it's only going to be for the most valuable data sets. If you're trying to build a podcast importance machine learning model, that's not super valuable right now. And so there is no out-of-the-box template that a machine could automatically pick up and run with. So that domain expertise, that knowledge, that experience is very difficult to automate, very costly to automate, and the ROI may not be there, and you would be better off having a data scientist with some generalized broad experiences of what goes into different types of models, being able to provide that feature imputation. So is augmented analytics or automated data science going to put us all out of business? No, not for a while. And by a while, I'm talking 5 or 10 years at a minimum. Machine learning models and AI models will keep getting better, and they will keep making our lives easier. But there's still a long way to go. Even with some of the most powerful new tools in the marketplace, like Auto AI from IBM and Auto ML from H2O, there's still a substantial amount of feature engineering that needs to happen up front, and it is as much an art as it is a science, which is frustrating for people like me who like to have processes that this is the best practice, just do it. Well, the best practice gets you the minimum level of competence for any given task, and then you have to add value on top of it. The good news is, for all of us who are domain experts in our various fields and occupations, our experience and our perspective and our ability to think creatively still matters and will still matter for quite some time to come. So great question, Michael. Very, very detailed question. Important to understand these distinctions to why automated data science will not just be a magic push of a button. And I could go on for hours about all the different examples where this falls down. So, but that is the short answer. As always, leave your comments in the comments below, please. And please subscribe to the YouTube channel and the newsletter. I'll talk to you soon. Want help solving your company's data, analytics, and digital marketing problems? Visit trustinsights.ai today and let us know how we can help you.